A very good morning to everyone. Let's begin with today's class. Let's crack CSIR-NET together. I'm your educator, Farida Bandookwala, and I've done my graduation, post-graduation, and MPhil in biotechnology. I've qualified MP SLET examination. I'm pursuing my PhD from DAVD, and I have a teaching experience of 10 years. Before beginning with the class, let us have a small introduction about Unacademy. Unacademy is one of the India's largest platform for the preparation of CSIR-NET, and if you are trying to prepare for CSIR-NET Life Science with Unacademy, what all you are going to get is you are going to get daily live classes, you are going to get structured classes, you are going to get live quizzes, and as I always say, it's very important to evaluate how you have learned so far. So live tests and quizzes can be helpful with that, and then you have unlimited access to all the videos which are in the category of CSIR UGC NET Life Science category. You'll get all those videos. And then Unacademy give you access to all the free live classes. Faculties they conduct free live classes on YouTube. They conduct free live classes on the special platform. So YouTube live class is like one which you are doing now. And what about the special classes is in special classes you have to download the Unacademy Learning app, and once you have downloaded the app you will make your account and are good to go. So you will follow my profile over there in the name Farida Bandookwala. Then there is one more thing, that is plus subscription. On this plus subscription you get all the 13 courses, 13 what to say subjects of life science, or 13 units of life science in a very systematic manner, well arranged manner. And the amount that you need to pay for this plus subscription is very popular. I would suggest go for a 12 monthly or 24 monthly subscription, highly helping you. And in this subscription also you can get a 10% discount if you're using my referral code, that is FP01. So do not forget to use my referral code FP01. So let us begin with the topic of that is HMP SHUNT. This is the topic of today. It is also called as Dickens-Horrocks pathway, and Horrocks pathway. So is it so that this is the only name? We haven't seen the full form of HMP as well. So HMP shunt has got many nicknames. So first of all, HMP, it stands for what? It stands for hexose monophosphate. Then it is also called as pentose phosphate pathway. Then what else? Why is it called as pentose phosphate pathway? Because a lot of the intermediates which are formed in HMP shunt are of the pentose sugar intermediate. Of HMP shunt. This is the alternative pathway for oxidation of glucose. Very important thing. Alternative pathway for oxidation of glucose. So, if it is the alternative pathway of oxidation of glucose, what is the primary pathway? Glycolysis. So, the term is very important. Now, this is alternative to glycolysis and alternative to cycle. Two things. Now, through this pathway, what is going to happen? The starting material for this pathway is always phosphate, and glucose 6 phosphate is going to put it into carbon dioxide. So that's why this pathway is also called as monophosphate, because of the generation various monophosphate in the pathways. It's also called as monophosphate pathway, also called as monophosphate pathway. And one more name, also called as phosphogluconate pathway. Phosphogluconate pathway. And along with this, it is also called as phosphogluconate oxidative pathway. Oxidative pathway. These are the terminologies which are related to HMP shunt. Now we are going to see actual pathway, and before beginning with the actual pathway, some of the things is that it consists of two important steps. Consists of two important steps. First is oxidative step. Oxidative step, and this oxidative step, it occurs in liver, occurs in adipose tissue, occurs in testes and ovary, occurs in the lactating mammary gland, occurs in the RBC. So this is about the oxidative step. Then second step is non-oxidative step. Non-oxidative step. So where does this non-oxidative step occur? Occurs in all the cells of the body. All cells of body. So if we are saying that it occurs in all the cells of the body, what is it doing? It's making pentose sugar. Making pentose. And pentose sugar is needed for what? Can you guess? Yes, everyone is thinking right that this pentose sugar is needed for DNA and RNA. Needed for DNA and RNA synthesis. Let's start the story. The story always begins in HMP shunt from glucose 6 phosphate, right? So 6 molecules of glucose 6 phosphate will participate. From glucose 6 phosphate, what is going to form is 6 phosphogluconolactone. 6 phosphogluconolactone. So I will just rub this 6 in front of gluconolactone. Sorry, 6 in front of glucose 6 phosphate, so you are not confused. So the 6 phosphogluconolactone, here the 6 is telling you about the position of the phosphate. So 6 phosphogluconolactone, and this step is accompanied by production of NADH from NADP. NAD gives rise to NADH. And this step is actually glucose 6 phosphate dehydrogenase dependent reaction, the enzyme which is performing this reaction, and this is a rate limiting enzyme. Glucose 6 phosphate dehydrogenase is a rate limiting enzyme. The rate limiting enzyme. Right. After 6 phosphogluconolactone, what is going to form is 6 phosphogluconolactone is going to change into 6 phosphogluconate. 6 phosphogluconate. 6 phosphogluconate, and this reaction is catalyzed by gluconolactone hydrolase. Gluconolactone hydrolase. If it's a hydrolase, there will be removal of water. Now 6-phosphogluconate is going to get converted into ribulose 5-phosphate. Ribulose 5-phosphate. And this is actually a 6-phosphogluconate dehydrogenase dependent reaction. 6-phosphogluconate dehydrogenase, the enzyme which is responsible for formation of ribulose from 6-phosphogluconate. Right. So here what is going to happen? One more NADP is going to get converted NADH, and carbon dioxide is also out in this place. Now we are saying that so much of NADPH is produced. So what is the use of NADPH? If NADPH is forming, there must be some utility. So it is used in the reductive synthesis of fatty acids. Fatty acid synthesis is used for cholesterol synthesis, is used for steroid synthesis. So NADPH has got lots of function, and the process of oxidative step of HMP shunt, it mostly occurs in liver and adipose, tissue. Now we'll be talking about the non-oxidative phase. Now how are we going to do this? We'll see ribulose 5-phosphate. It is going to get converted into two products, that is xylose 5-phosphate and ribose 5-phosphate. So this ribose 5-phosphate precursor for DNA and RNA. Now they both are going to get changed into two other products, and the enzyme required for this kind of reaction, formation of xylose 5-phosphate and ribose 5-phosphate from ribulose 5-phosphate, is epimerase and isomerase. Epimerase and isomerase. So this is going to give rise to pseudoheptulose phosphate, pseudoheptulose 7-phosphate, and going to give rise to glyceraldehyde. Glyceraldehyde. And these things, they are going to give rise to other products, that is erythrose 4-phosphate and fructose 6-phosphate. Now as I told you that there are 6 glucose molecules which are actually participating in this. So let us write that how many ribulose 5-phosphate will produce? 6 ribulose 5-phosphate. How many xylulose will be there? There will be 2 xylulose and 2 ribose and more xylulose, and from this there will be formation of 2 pseudoheptulose and 2 glyceraldehyde molecules, and there will be formation of 2 erythrose fructose. And you know what, this xylose and erythrose, they are going to react and they are going to give rise to 2 molecules of fructose phosphate, and they are going to give rise to 2 molecules. What is happening? molecules of glyceraldehyde, this is going to happen, right? So this is the oxidative phase of our HMP shunt. So in oxidative phase, there is liberation of carbon dioxide through decarboxylation. So this is the non-oxidative phase. So previous to this, there was oxidation phase, and in oxidation phase, there were actually liberation of 6 carbon dioxide. Total 6 carbon dioxide are liberated in oxidative phase. Story of oxidative phase and your non-oxidative phase. Now talking about the fructose 6-phosphate. So fructose 6-phosphate, there's generation of 5 molecules of fructose 6-phosphate and which regenerate the 5 molecules of glucose 6-phosphate. So I'll just show you over here. See, 2 fructose 6-phosphate over here and 2 fructose phosphate over here, and one more fructose phosphate is formed. So total fructose 6-phosphate, whichever is forming, they are going to give rise to the molecules of glucose 6-phosphate. So overall, there will be regeneration. So there will be regeneration of 6 molecules of glucose 6-phosphate in the whole pathway. And the glucose which is oxidized in the HMP shunt, where is it used? So 10% of the glucose is oxidized by HMP shunt. So 10% of the consumed glucose consumed is oxidized in HMP shunt. And liver and RBC, it use the 30% of glucose from HMP shunt. Now let us talk about let us talk about the whole process in a very uh, compact manner. So 6 molecules of glucose 6-phosphate will react with 12 molecules of NAD. This and it is going to react with molecules of water, and we are going to get 5 molecules of glucose 6-phosphate. In the end, we are going to get 12 molecules of NH plus we are going to get 12 protons plus 6 molecules of carbon dioxide. So this is how the whole process of HMP shunt occurs. The whole thing HMP shunt occurs. Now we are also going to talk about the importance of HMP shunt lastly. So what is the importance of HMP shunt? Importance of shunt. So NADPH formed in this whole process. We have seen many of the utility of NADPH. Another utility of NADPH, that it is the source of NADP, source of energy. Then about the pentose sugar is source of various nucleic acid molecules. So that is DNA, RNA, AT, FAD, NAD, OA. Various places it can be used. So it is quite important thing in the body. So this is it. We have completed HMP shunt in, and in the next class we'll be talking about maybe electron transport chain or Krebs cycle. Or if you want to, you can write in the comment box. So lastly, as we say, let's crack CSIR-UGC together. and please hit the bell icon for getting all the notifications of the upcoming video. And lastly, if you like my video, give it a thumbs up. It really motivates us. And lastly, if you are going for plus subscription, do not forget to use my referral code, that is FT01, and you know that you are going to get a 10% discount if you are using my referral code FT01. So this is it for now. We'll be meeting with another video. It for now.